Okay, welcome to the class COM 224 Management Information System. It's for National Diploma in Computer Science. I want to give kudos and appreciation to this body who provided this material, UNESCO Nigerian Technical and Vocational Education Revitalization Project Phase 2. We appreciate you for giving this material. I will be using this material for this course. Let's go to week 1. Management Information System. We are talking about system here, so let's talk about the general system theory. And we have types of system. I will describe them as we go on. We have systems, we have subsystems, and we have super system. Pardon my tongue. Then talking about system can be described as a group of interrelated elements that are integrated together with the common purpose of achieving a particular objective by accepting inputs and producing outputs in an organized transformation process. That means the input is worked on, is processed, is transformed, then the result is outputted. Now, by definition, let me help you. A system is when you gather some elements together to work together to achieve a common goal. A system, like an organization, can be called a system. A firm is a system consisting of physical resources like manpower, material, machines, money, and conceptual information. They work towards achieving a particular objective. They work together, cooperating together. That's a system. Each of the departments working together. This works on the information. This one puts his own have his own input on the information. This one checks the information. This one processes the information. This one presents the information. That's a system. All those departments, all those parts, all those elements working together. Okay. Now we have types or examples of systems. We have biological system. We have business system, electrical system, data system, education system. We have operating system, mathematics system, sound system, waste disposal system. We have computer system and querying system, among many other. The general system theory states that a system is a totality where the whole is greater than the algebraic sum of all the individual elemental parts of the system. You understand that? A system is a totality, and the whole, a system, the whole is greater than the algebraic sum of all the individual elements of that system. So individually you add them together, they are not still as good enough, but when they work as one, then they are the best. Therefore, it is professionally correct for a manager to consider his or her organization as a system. Yes, consider it as a system, because a system is greater than the sum of all the elements in the system. It has more result, better result. So work as a system. Consider your organization as a system if you want the best result. Now, such a manager will have made problem-solving process easier and more effective. Let's go to subsystem. We have talked about system. Let's go to subsystem. Just briefly, a subsystem is a system inside a system. A system inside a system. A subsystem is a system itself. but it exists inside another system. It has its own specific goal. Say, this is what I want to achieve. It achieves it, and it gives the result. But there's another system that picks its result and uses its own result. So a system working for another system, a system inside a system, that's a subsystem. Now a super system, you can read it through, please. You can read it through. A super system is a system that has a system inside it. This one has a subsystem inside it. Yes, a super system is the system that makes other systems to work for it. I would like you to give me examples. When you mention subsystem, give me examples. You describe super system, give me examples. You describe system itself, give me examples. Now, basic element of systems. A basic configuration of system consists of the following elements. When you're talking about a system, you have need of input. There will be input element. There will be transformation process, and there will be output element. Yes, there will be input to that system, and there will be transformation processing in that system to give a result, and the result will be brought out as an output. So and we have some systems that have feedback loops. They have control mechanism. They have objectives. Input resources are transformed into output resources by processing. The resources flow from the input element through the transformation element to process it. Then it will now go to the output element. Now, a control mechanism is one that regulates the transformation processes so that it will ensure that the system meets the objectives. A control mechanism is connected to the resources flow by means of a feedback loop, which obtains information from the system output and makes it available to the control mechanism. Shall I explain that? That you have a set target. In my system, this is what I want to achieve. You have a set target. So when you begin to produce, you now bring back a little of the output. You want to see whether it meets up with a standard. So the feedback, we bring it back to the control system. The control system will compare. Is the output as good as the desired output, the set output? Is the output as good as the set output? Is it as good as the objective? So when that is compared, if there is a little more, it will increase it. If there is too much, it will decrease it. Adjustment and correction will be done by the control system so that a perfect output can be obtained. So the control mechanism compares the feedback signal to the objectives and directs signal to the input element when it is necessary to change the system operation. Look at the diagram here. The objective is set. The feedback is brought to the control system. So it will now compare the feedback with the objectives and make necessary adjustments in the processing. More explanation here. A feedback is data about performance of a system. That's what we mean by feedback. How is the performance? How is the output? So a feedback is a data about the performance of a system. Now, these are the processes Number one, specification planning. Specification planning. This is like you set objective. This is what we expect. This is what we target. Number two, collecting facts. Now, like we said, the fact will be collected from the output and it will be brought to the control system. Number three, comparison. This will compare what is set with what has been produced for adjustment. Then number four, the adjustment, corrective action. Yeah, all those things are what happens in a control system or mechanism. Not all systems are able to control their own output, their own operations. So a system without control mechanism, no feedback loop, no objective element, that system is known as dynamic system. Dynamic system. So no input. No feedback. No control mechanism. It's dynamic. When we talk about input involves capturing and assembling elements that are used for feeding the data to be processed. Input. You see, when you have a system, something comes in before you start to process it. That's the input. Number two, processing. When we talk about system, you have need of input, then processing, which involves transformation processes that convert input into meaningful output. When you give me this, you give me examples. Give me examples. Input, processing. Number three, output. This involves element that communicates the results of processing to the outside world. This is all about communication. What has been received as at input and has been processed has to be communicated to the outside world. Yes, give me examples. Number four, feedback. For the systems that have control, they have feedback and all that. Feedback is defined as data about the performance of a system. Also give me an example. Look at the example there. Number five, control. The control part involves monitoring, regulating and evaluating feedback to determine whether a system is moving towards achievement of goals. Yeah, control system. All that. Let's go to taxonomy of systems. There are three categories of systems. We have probabilistic system, we have cybernetic system, and we have deterministic system. Let's talk about the probabilistic and the deterministic systems. Probabilistic system can also be called stochastic system. This is the one whose outcome can be predicted with precision. Cannot be predicted with precision. When we talk about probability, it's under probability. You cannot predict the outcome. You know why? There's a reason. And I want you to read the reason and tell me the reason. You cannot say this is what we are going to achieve, because they are subject to some influences. Then, like the economy, you cannot predict the economy because you don't know what will happen tomorrow. The new government can come and increase fuel price. The economy is affected. So it's a probability that what you have predicted will come to pass or not. It's a probability. Like agricultural system. If you plant 3 seeds Maybe you are expecting three tubers from 3 seeds, but there is flood tomorrow. So flood will affect, climate change will affect, so you cannot actually predict accurately, precisely. Let's talk about deterministic system. This is a system also called mechanistic system, whose behavioral pattern can be predicted if its present state and operation characteristics are known. You can predict the output here if you know the state and the operation characteristics. Give me an example. A computer system. You know that you have kept a program there. The program is error free. Then you can say, yes, it will give me this output. A computer system can do multiplication for you. As long as the computer system is in good condition, you can press button and say 2 times 2. You know, you get the accurate result. So that is deterministic system. Let's go to cybernetic system. Cybernetic system. Now, it is also known as, a cybernetic system is one that automatically adapts to its environment. This one will automatically adapt to its environment. Yes, a system with feedback and control is sometimes called cybernetic system. It will adapt. Like air conditioner system. You can set your air conditioner system to a particular temperature. Say, I want this room to be 22 degree cold. Let it be at 22 degrees Celsius. You set it 22. So the air condition system will try to perceive the temperature, then give out something to balance it, to drive it towards the set target. It adjusts itself. I don't know, I don't have a better example right now. So that's the system, cybernetic system. It will adjust to get feedback from the surroundings and adjust. It's a self-monitoring, self-regulating system. The behavior of the cybernetic system is a subject of rigorous scientific investigation. Can we talk about one more? Adaptive systems. Adaptive systems. These are dynamic systems which respond to changing circumstances by adjusting its behavior on self-organizing basis. This is under cybernetic systems. But this one, it will respond by changing its behavior. To just change its behavior. Maybe it's in Rome. It will change its behavior so that it can be like Rome. Can be like a Roman. The system alters its parameters as a result of measuring output. Example includes organizational systems such as human beings. The degree to which a business is adaptive depends to a great extent on the caliber of its management. If they cannot adapt, well, that business will not succeed. And that's the end of week 1 for this system management, information management system. Thank you. Stay tuned. Please subscribe and like the video so that we can give you more. Thank you.